Welcome back to a new episode of Chico Study Corner, and today we'll be doing the second part of the video of light, reflection and refraction of physics class 10. So we've already finished the reflection portion. Now we'll be dealing with refraction, lenses and glass slabs. So let's get into the video. First, I already told you what refraction is. The bending of light ray when it moves from one medium to another. When does bending happen? That was given by a beautiful example. A man in a sea and two people on the shore running. That is the reason. So, refraction happens if someone asks you, why does light bend? Or what is the bending of light? We usually say it is because of refraction that light bends. Actually, it is not because of refraction. The bending of light is called as refraction. Next, we know that if there should be a refraction, there should be two different mediums. So each medium should have some differences. So if the density of these mediums are different, they are called as optically rarer medium and optically denser medium. Now we'll take an example. We'll take a sponge and a sponge and an air. So if light passes through the sponge, it has to go through this because this is more dense, this is more heavy than air. So it will come fast, slow down and then go out. This is because this is called the sponge is the denser medium and air is the rarer medium. We have got a property, or we have got a beautiful fact that happens always. So when an object moves from a rarer to denser medium, it moves towards the normal, and when it moves from denser to rarer medium, it moves away from the normal. How can you relate that? So you think you are running very fast. When you are running very fast, you come across a place with a puddle of water and then you slow down. You have to obviously slow down. Again, when the puddle is fully gone, then you can run faster again. This is just think of it. When you move from a free medium to a little more molecularly attracted medium, there would be change. Now, we discussed about what rarer medium, what denser medium is. So we'll get into what refractive index and what the laws of refraction are. As we discussed about the laws of refraction in the first video, and there I told you about this first law of refraction, that is the ratio of sine of angle of incidence is to the angle of refraction is a constant. That is called as Snell's law, and that constant of a medium is called as the refractive index. So what is total internal refraction? This is happening only after the critic point. The critic point is in case take this as a glass slab, and if the light ray comes like this and touches it at a single point, it will go like this. This angle is known as critic angle, the 90-degree angle. And if this light comes from here, it will refract in the same medium itself. This is called as total internal reflection. And this happens only when it is crossing the critical angle. Now, we've learned that refractive, what is refractive index actually? So, refractive index, to be precise, or if someone asks you for a definition of refractive index, you have to write like this. The refractive index of medium 2 with respect to medium 1 is given by the ratio speed of medium 1 and the speed of light in medium 2, and that is the definition. This is usually represented by the symbol n21, that is the medium n in the medium of 2 is to 1. This is 2 by 1. I mean, that's actually 1 by 2 when you say it is in the reference of 2. That is when you say of a glass. If you want to know the refractive index of a glass, you write the refractive index of glass by the refractive index of air. So in terms of air, the refractive index of glass that is what we say. That is N21. And now we have to learn about two we have to remember two refractive indexes, that is, one is of air and one is of the glass slab and one is of water. So air we will be discussing later, and water, what is the refractive index of water? When there is nothing mentioned, it's just given refractive index of water is it's actually 1.3. So if it is given like that, it is in respect, or refractive index is in respect to air or vacuum. If it is mentioned refractive index of water in respect to glass, then you can understand what it is. We'll be discussing questions, so it will be easier. And now we are going to do about the refraction in a glass slab. So now glass slab is having more density than air. Then how is refraction possible? I told you. Now we take we draw a parallel or a, okay, it's a ray is falling obliquely on a glass slab. This is the glass slab, and the ray is falling obliquely, and this will refract. As I told you, from rarer to denser, it will move towards a normal. For in case this part is the normal, so the light ray will come and then it will go towards the normal, and when it moves out, it will go away from the normal. I will show you the diagrams. Don't have to get worried about it. So that's how you do it. And glass slab, that we know that sin I by sin R is a constant, and it is called a Snell's law. This has to be put practical in the glass slab's case. Now, if there's a refraction in multiple medium, obviously you will think, if from air, then it comes to glass, then to water, then to oil, then to kerosene. If all these mediums are kept one by one, we will think the refraction will not happen properly. But actually it will happen, because after a layer of water, and then after a layer of air, then comes water. After that also a small layer of air comes, and then comes oil, or then comes glass. So there is no change, or there is a proper refraction taking place. Then like where is refraction used, or like how can you say this an example for in refraction? You can take actually there are, when you learn about refraction, you learn about the magnifying glass and the paper burning experiment. So that is because the whole of the light is focused to single point. Now we will be learning about spherical mirrors in spherical lenses in this chapter, that is concave and convex lens. So actually, what is a lens? Lens is it's a transparent medium through which light can pass through actually. So what is a spherical lens? We learn lens is a transparent medium which is formed, that this, like, you know, the spherical lens is a transparent medium which is formed by two spherical lenses forming together. These two spherical lenses can be like, you know, like a bangle, or like this in a peanut shape, or can be the opposite, like this, like a vase shape, a vase shape. So this is they are the two mirrors, lenses that we have to learn. So what is convex lens? It is a lens which has thickness, or thicker in the center and thin in the outer side. It's convex. Convex lens is like this. And concave lens, it has the inner portion or the middle portion thinner and the edges thicker. We've learned about both what concave and convex lenses are. Now we have to learn the terms related to these lenses. So first we have to know what optical center of a lens is. Actually, I told you lenses are made of two circles. It comes together to form one. So there are two centers for a lens. So we have to find only one. That is, that one center is called as the optical center. So that if someone asks you what an optical center, or a question comes for your board exam, what is optical center, the definition goes like this. It is the center of the lens through which light can pass through without any deviation. This I will teach you, because we have to learn how to draw a diagram, so we learn in it. Then next we have to learn about the principal axis. It is the same thing, the line joining the optical center and the center of curvature. A straight line joining the optical center and the center of curvature is called as about the principal axis. Then we have to learn about the focus. Focus, as we all know, it is the point at which all converges. And this focus. If someone, if for example, a question comes in your question paper, or when you go for an interview, if someone asks you what is your name, you just don't conclude by saying my name is Dia. You say my name is Dia Marin Jacob. Like that, if a question about the focus or the about the focus come for the exam, you have to write it as principal focus. Its initial is principal, don't forget. Principal focus. Now, what is a principal focus? It is a point on which the principal axis where all the light rays are converging. I told you the same thing. Now, we have learned about the types of lenses, and we've learned the parts of a lens and the new terms of lenses. Now we learn about how to draw the ray diagrams. So first, if a line goes parallel, if we learn about convex lenses at first. So if a line or a ray is parallel to the principal axis, it will go through the focus. That means if it is coming from the F1 side, the F2 side focus, it will converge. And it is the vice versa for the same thing. And then, this is one, and if goes through the optical center, it will retrace its path. Now, we'll learn about the formation of these images. So, now we have this concave and convex lenses. So, we'll learn about them. First, there's concave lens. So, this is a concave lens. Image formed by a we learn about convex lens. Image formed by a convex lens when the object is beyond 2f2. F2 is, we learn what F2 is. That is the focal, focus in the second side, or F1 is a focus in the first side. So first the image is over, the object is over here. And then I told you, if the light ray is parallel to the principal axis, it will go through the focus in the second side, and in the first one, if it passes through the optical center, this is the optical center. If it passes through the optical center, it will retrace its path. And then this is the first one. We have completed the first one. Now the second one. I think you can see this. If you can't, please let me know. Yeah. Oh yeah, this is the image. Okay, the image formed by the convex lens when the object is at 2f2. That is, the object is kept at 2f2. So the image is formed at 2f2. The object is kept at 2f1. So this is the image, and as I told you before, the same thing, parallel rays coming over here, image is formed over here. Most of these images are by a lens is always, inverted. So you can see in this case it's inverted, in this case it's inverted. So you form an inverted image. Over here, image formed beyond f2. It's real and inverted. It's given it's real and inverted. See, over here the object is placed, and this is actually a parallel line. It's a bit slanting. This is a parallel line. It passes through the focus of this lens, and then this passes through the optical center, and the image is formed over here. And as you all know, most of the images are formed in the opposite side. If it starts from here, it's formed over here. Only two cases where image is formed behind on the same side. That is called as virtual images. They are always erect and most probably enlarged. So now we have finished this also. Now we have come to the fourth one. This is where we form a virtual image. This is the eye. From here, when you look, or see, this is the object, and this is a parallel line. It passes through the focus and it goes, and this is a line that retraces its path because it goes to the optical center. It's actually going to the optical center. Small mistakes It's actually going to the optical center. We'll assume the optical center to be here then. So it goes to the optical center. And you can see this won't meet anyway. If you extend it somehow also it won't meet because it's going away. It's not parallel also. So when you join it backwards, if you join it like this, you get the image. Yeah, this is not straight, but still you get the image. This is a virtual image. This is a virtual image and this is formed on the same side where the object is kept. It is highly enlarged. This is a virtual because we cannot actually see the light rays meeting. We are extending it backwards to make them meet. And then here the object is kept. Okay, here it is a virtual and erect image and it's enlarged. So here the object is kept between the optical center and the F1. So over here, as I told you, the parallel rays, it goes to goes to the focus, and this is actually very diverting, so it will never meet. It will go like that, and when you extend it backwards, it meets over here, and this forms an image in the same side, which is enlarged and which is virtual. So we've learned what convex lenses are. Okay. Now we'll be dealing about concave lenses. So now we know what concave lenses are, and we'll be dealing with the ray diagrams. And let's see. This is a concave mirror. As I told you, this is a vast shape. It is curved inward. It has a curved surface. As you can see, it was not like the convex mirror like this. Okay. Now, for this picture or this ray diagram, the object is at infinity. You can't see where the object is. So from there, the light ray comes parallel, and to be precise, you can say that concave lenses are diverging lenses. So they diverge the light. See, it goes apart. It is not coming or meeting at any point actually. So we drew it backwards because if there's an eye who looks from here, they would see it as this is being joined over here. For their eyesight, it is being joined over here. So here is the image form. It is highly diminished and it is on the same side. It is a virtual image. And when the object is beyond F, not beyond 2F, when it is beyond F, it's just F. Over here we'll keep 2F. Okay. If here is 2F and it is not beyond 2F, it is beyond F, then if the parallel rays go, it diverges and it forms an image between the focus and the optical center. Here is the optical center. Between the focus and the optical center, there forms the image over here. The image is small. It is comparatively small than the object, but you can see the image. So this is what we have learned in this chapter of the lenses. Now we'll be dealing with the focus and the the object distance, the image distance, etc. So as we learned for the mirror, we have a mirror formula, and for lens, obviously we'll have a lens formula. That is 1 by F is equal to 1 by V minus 1 by U. Just don't forget the symbol. It is 1 by V minus 1 by U, and for mirror formula it was 1 by V plus 1 by U. Over here it is 1 by V minus 1 by U. And now we are learning about magnification. What is magnification? So general formula of magnification is HI by HO, but in case of lens it is positive, V by U. So we'll learn about, we'll do some sums on this. I'll give you some questions. And let's get, if the height of the image given is less than 0, it is erect. If it is more than 0, it is you will get all these answers. So when you do when you do each sum or each problem related to magnification, what we have to be careful is about the sign convention. To be precise with the sign convention, when it is a concave lens, it is the focus the focus or the focal length is negative, and the P, the other one is positive. The P is positive and F is negative in case of concave lens, and in case of convex lens the F is positive and P is also positive. Now we've learned about what P, what F and what all are it is. Now the unit of magnification of a lens, or what is the unit of power of a lens? That is diopter. Diopter is the focal length per meter. So if a question comes, explain or define one diopter, that is the focal length in 1 meter, or 1 meter focal length, and its reciprocal is the power. So we have learned that now we know power, it is represented by P. Power is equal to 1 by F. So you can see power is equal to 1 by F. This is a formula that we have to learn. And over here we have to always think, if a question comes and the F is given as centimeters, you have to convert it to what? Meters. But if you don't convert it to meters, you can't put the unit of power as diopter. Okay. Then now we'll be discussing one question. We have almost completed all the portions of this chapter. Now we'll be doing one question, and I'll be discussing one question with the answer, and I will give you 3 questions. So let's see. The first question. An object is placed at a distance 30 centimeter and the image is formed at a distance of 10 centimeter on the same side of the lens. On the same side of the lens. So you can imagine that is a convex lens. Concave lens. Okay. On the same side of the lens. Then find the focal length of the lens used. So this is the answer for the question. We know that that is what we learn now. We have to apply the lens formula of here, over here. This is the lens formula. This is the lens formula. 1 by F is equal to 1 by V minus 1 by U. Okay, it is 1 by V minus U. If you put 1 by U minus V, you won't get the answer. Okay, so we know that the V, the value, that is the image distance is minus 10 and the object distance is minus 30. So we have to substitute in this formula to find 1 by F. Over here it is equal to 1 by F. If you don't write that for your examination, the examiner will cut marks. So this is equal to 1 by F. Okay. Yeah. So my 1 by minus 10, I have written this is minus 10 minus 1 by minus 30 is equal to 1 by F. So when you add it, you get is minus 3 by 30 plus 1 by 30 is equal to minus 2 by 30. That is equal to 1 by F. So F is equal to reciprocal. So F is equal to 30 by 2. That is minus 30 by 2. That is equal to minus 15 centimeters. This is such a simple question. This is very easily done. So power, we have to just think of the things. If a question of power comes, we have to just think of conversion of it. Nothing else is very important. You have to be sure about the sign conventions. Nothing else matters big. So now I'll give you 3 questions, and if you find the answer, please leave it in the comment box below, please. If it is correct, I will tell you, and if you want the answers for those questions, please let me know through the comment box. So the 3 questions are, they are not numericals. If you want numericals, if you are so keen to know what the numericals are, you can give me in the comment box. And also if people want to know about the derivation of lens formula and mirror formula, you can ask me, or I will put in the description if I can. Okay, so the questions are, the first one, how many images of himself can an observer see in a room whose ceiling and the 2 adjacent sides are made of mirror? If the ceiling and 2 adjacent sides, if it is like this, if a corner and the rooftop is made of glass, mirror, how much images will you see? That is the first question. And the second question is, if the light from the sun subtended at an angle theta, angle is not mentioned, at the pole of a concave mirror,
of focal length f, where will it converge? Also find the diameter of the image. So that is the second question. And the third question, that is the last question. Express the refractive index in terms of n of a medium whose speed of the light, first one is the speed of the light, second one is angle of incidence and the angle of refraction. So the third question is express the refractive index n of a medium in terms of speed of light, angle of incidence and angle of refraction. So this is all in this session, and we've come to the end. Hope you have liked it, and if you have any queries or if you found anything wrong in me, you can ask me in the comment box below. And please do not forget to subscribe and hit the small notification, that bell button, and like my video, share as much as possible. Thank you for watching. Bye bye.